friends, a very warm welcome to the discussion of another topic pertaining to CSAT examination. Today's topic is one of the most popular topics based on which questions appear in CSAT and similar examinations. And today's topic is time and distance. So let us first of all have a look at the basics and then move on to different patterns, to different questions based on various patterns. Now, when we talk about time and distance, the relation between distance and time is called speed. As you might have learned in your earlier classes, that speed equals total distance covered divided by total time taken to cover that distance. So speed equals distance by time. Now we can write it in different ways. That is, distance equals speed into time, if we take time here on the left hand side, and time equals distance by speed if we interchange speed and time in this formula. So basically, this is the formula based on which you have to solve the questions. And how was this formula derived or arrived at? Let us say D is the distance covered, T is the time taken to cover that distance, and S is the speed at which that distance is covered. So assuming that we have to cover a distance of 100 kilometers, which means that the distance to be covered here is constant. Then what will be the relationship between speed and time? Well, more the speed, less will be the time taken, and lesser the speed, more will be the time taken. So if we are going at higher speed, time taken to cover a distance obviously would be lesser. So speed and time, they have an inversely proportional relationship. That is, if speed is greater, then time will be lesser. If speed is lesser, then time taken will be greater to cover a constant distance. Now let us say that you borrow your dad's car and he allows you to drive only for 1 hour. That means the time period for which you will drive the car is constant. It is only 1 hour. In that case, more your speed, more will be the distance covered. Lesser your speed, less will be the distance covered. So here we find that speed and distance, they have a directly proportional relationship. That is, greater the speed, greater will be the distance covered. Lesser the speed, lesser will be the distance covered if the time period is constant. Now let's take another case wherein you are driving on a highway and you have to drive at a constant speed. So let us say you are driving at 60 km per hour, neither below this nor above this. Constantly at 60 km per hour you are driving a car, let us say. Then more the distance that you have to cover, more the time required to cover that distance, lesser the distance that you need to cover, lesser will be the time required to cover it. So as to say, distance and time are directly proportional. More the distance, more will be the time required to cover that distance at constant speed. Lesser the distance to be covered, lesser will be the time required to cover that distance. So from these three relationships, the formula, that is speed, from this we get equals distance, and from this we get by time. And most of your questions would be solved just using this particular formula. Now the speed could be measured in terms of kilometer per hour, meters per second, it could be meters per minute as well. Usually the questions that appear in the examination, they use kilometer per hour or minutes or meters per second as a units for speed. Now many a times you need to convert kilometer per hour into meters per second depending on the instructions given in the question. Now when we talk about a kilometer per hour, it means 1 kilometer by 1 hour, and if we want to convert it into meters per second, we know that in 1 kilometer there are 1000 meters, and in 1 hour there are 60 minutes and each minute has 60 seconds. So hence 60 minutes into 60 seconds. So this becomes 1000 by 3600. So when you cancel these two, this is 2 into 5 is 10, 2 into 18. So you get 5 by 18 meters per second. So 1 kilometer per hour is 5 by 18 meters per second. So whenever we want to convert kilometer per hour into meters per second, you have to multiply kilometer per hour with 5 by 18 to obtain speed in terms of meters per second. Now conversely, if you want to convert speed from meters per second into kilometers per hour, you will have to multiply meters per second with 18 by 5. Obviously, when you want to convert meters per second into kilometer per hour, this shall go there on the right hand side, and 1 meters per second into 18 by 5 shall give you 1 kilometer per hour. Now, in order to save time, you should memorize certain conversions from kilometer per hour to meters per second. And for that, I give you a table here. If the speed is 18 kilometers per hour, then you know that 18 into 5 by 18, 18 will cancel. So you will be left with 5. So that is equivalent to 5 meters per second. Now double of 18 shall be double of 5. That is 10 meters per second. Triple of 18 shall be triple of 5. That is 15 meters per second. Triple of 18 is 54. Triple of 5 is 15. Now similarly, 4 times 18 is 72. So 4 times 5 is 20 meters per second. So 72 kilometer per hour is 20 meters per second. And 18 into 5 is 90. So 90 kilometer per hour will be equivalent to 5 into 5, that is 25 meters per second. And 18 into 6, 108. So 5 into 6, 108 kilometers per hour shall be equivalent to 30 meters per second. Now apart from that, half of 18 is 9. So 18 into 1.5 or 18 plus 9, that is half of 18, shall be equal to 27, and 27 kilometers per hour will be equal to 5 into 1.5, that is 5 plus half of 5. Half of 5 is 2.5. When you add them together, you get 7.5 meters per second. So it really pays off if at all you memorize these conversions so as to save time while performing calculations during the examination. Now let's have a look at a question here. In how much time? So what is it that you need to find out? You need to find out time. Will a car traveling at a speed of 72 kilometer per hour? Now what is given here? Speed is given to us, that is 72 kilometer per hour. Cover 180 kilometers of distance. So distance is given to you as 180 kilometers. So simple as that, you know speed is equal to distance by time. And what you need to find out is time. So time equals distance by speed, which is 180 kilometers by 72 kilometer per hour. Now, very important, please make sure that you take care of the units. We know that 36 into 5 is 180 and 36 into 2 is 72. So the total time taken to cover 180 kilometers of distance at a speed of 72 kilometers per hour shall be 2.5 hours. A very, very basic question. Now kindly look at the next question here. A man travels in his car at 56 kilometer per hour. Now speed is given to you as 56 kilometer per hour and completes his journey in 5 hours. So time period is also mentioned here. So speed is 56 kilometers per hour. Time period mentioned is 5 hours. At what speed should he drive the car to cover the same distance in 7 hours? So let us say this is T1. Initially, at this speed, the man is taking 5 hours to cover a particular distance. Now he's saying the same distance now needs to be covered in 7 hours. Now in such a case, what shall be the speed? Now we know that speed equals distance by time, and from this basic formula, we also know that distance is speed into time. So the distance here in either of the cases That is the first case when this distance is covered in 5 hours, and the second case when the distance is covered in 7 hours. The distance remains the same. So that means S1 T1 shall be equal to S2 T2. Now this becomes 56 into 5 equals S2 into 7. 7 and 56 they cancel, go by 8. So the speed at which the man should travel to cover the same distance in 7 hours will be 8 into 5, that is 40 kilometers per hour. Next question. A bus travels from city A to city B at a speed of 50 kilometers per hour and comes back by the same route at a speed of 40 kilometers per hour. If the bus takes an hour extra while coming back, then what is the distance between the two cities? Now there are two cities which are given to us here, city A and city B. When the bus goes from city A to city B, the speed is 50 kilometers per hour and the time taken, let us say, is T hours. And while coming back, the bus travels at the speed of 40 kilometers per hour, but this time the time taken is an hour extra while coming back. So that is T plus 1. Obviously, the distance between the two cities while going and coming back remains the same because he is coming back via the same route. Now, the difference between the two timings is 1 hour. To travel from B to A, time taken is TBA. From this, if we subtract the time taken to travel from A to B, then this shall be equal to D by speed of the bus from B to A minus D by speed of the bus from A to B. Well, we know time is nothing but it is distance by speed. So employ the same formula. Now between the two timings, the difference is already given to us as 1 hour, and D being the distance, which is the same in each case while traveling from A to B or from B to A. And speed from B to A is given to us as 40. So it goes here, and speed from A to B is given to us as 50. So it goes to this particular part. And obviously distance is what we need to find out between the two cities. So that is D. So finally you are left with only one variable, and simply you can solve this. Now 1 equals the LCM of 40 and 50 is 200. So this shall become 5D minus 4D by 200. Now 5D minus 4D, you know, is D. 200 goes here. So the distance between the two cities is 200 kilometers. Next question. A person completed 80 kilometers of journey in 7 hours. Now the distance is given to us as 80 and time is also mentioned as 7 hours. Now he covered a part of his journey on foot at 8 kilometers per hour and the remaining part on bicycle at 16 kilometers per hour. So how much distance did he cover on foot? Now we know that, let us say that these are the 2 points, point X and point Y. The distance between these 2 points is 80 kilometers. It's already given to us. The total time taken is 7 hours. Now a part of the journey is covered at a speed of 8 kilometers per hour. Now this is on foot, and the remaining part is covered on bicycle at 16 kilometers per hour. So let us say that if this distance which is covered on foot, and this is required to be found out, so let us assume this as X. Then the remaining distance shall become 80 minus X kilometer. So how much distance did he cover on foot? Now the total time taken to cover this journey will be equal to time taken to cover the journey on foot plus time taken to cover the journey on bicycle. Now we know time is nothing but it is distance by speed. So let us employ this formula. So total time taken here is given to us as 7 hours. Now that is equal to time taken to cover a distance on foot. How much distance is being covered? Well, that is what we need to find out, which we have already assumed as X kilometers. So this is X by speed is given on foot. He covers a distance of X kilometers at 8 kilometers per hour plus the remaining distance 80 minus X kilometers is covered at the speed of 16 km per hour. So 8 and 16, the LCM is 16 only. So 7 here equals 2x plus 80 minus x by 16. So now 7 into 16 equals 2x minus x is x. So that is x plus 80. That's what remains on the RHS. So 16 into 7 is 112 and minus 80 shall give us x, which is nothing but 32 kilometers. So the person covers 32 kilometers on foot and the remaining distance, that is 48 kilometers, he covers on bicycle. Then the total time taken here becomes 7 hours. Let's have a look at another question here. A thief steals a car at 2:30 p.m. and drives away at a speed of 80 kilometers per hour. Now let us say that there is a house from which a thief is going to steal a car and he does that 2:30 p.m. This is the time at which the theft takes place. Now the theft was discovered at 3 p.m. Now 3 p.m. is the time at which theft is discovered and the thief is chased by a policeman at 100 km per hour. Now let us say right now the time is 3 p.m. What's happening? Now here, let us say this is a gypsy and the policeman has started chasing the thief at a speed of 100 km per hour. But where is thief right now? How far is thief from the starting point? Or let us say how far is thief from the house from which he has stolen the car? The thief has to be somewhere here, let us say, and he is already traveling at 80 km per hour. So this is where he is at 3 p.m. Now this is the thief. So how much is this distance? He is traveling at 80 km in 1 hour. So from 2:30 to 3 p.m., half an hour period. In this half an hour period, how much distance has he covered? Half of 80 kilometers. So the distance between the policeman and the thief, when the policeman starts chasing the thief at 3 p.m., shall be 40 kilometers. So what do you need to find out? At what time will the thief get caught? So we know time is distance by speed. So time taken for the thief to get caught by the policeman shall be distance by speed. Now the speed here, when both the bodies are moving in the same direction, that is, both are moving in the same direction. So the concept of relative speed will come into play. And if both the bodies are moving in the same direction, in that case we take the difference of their speeds. So it shall be 100 minus 80. So what we get is 40 by 20. That is 2 hours is the amount of time taken by the policeman to catch the thief. But the question is at what time? What time? So the time here should be after 3 p.m. Another 2 hours get added to it. So the thief gets caught at 5 p.m. Now, if the speed of a student is 4 km per hour more than his original speed, then he reaches his college 20 minutes earlier. Whereas if his speed is 2 km per hour lesser than his original speed, then he reaches 40 minutes late to his college. How much was his original speed? Now, in such a case, we will use one concept. If a person covers a distance traveling at m km per hour more speed than the usual speed, then he reaches his destination t1 hours earlier. If the person travels the same distance traveling at n km per hour lesser than the usual speed, then he reaches his destination t2 hours late. In such a case, his usual speed is found using the formula mn t1 plus t2 divided by mt2 minus nt1 kilometer per hour. So simply employing this formula, we will find out the answer to the previous question. So let's do this. Now original speed, as we know, we will use this formula mn t1 plus t2 by mt2 minus nt1. Now let us define these M and N. M is when it is 4 kilometers per hour more than his original speed. So M here becomes 4 and he reaches 20 minutes earlier. So T1 here is 20 minutes. Let's convert this into hours. Shall become 20 by 60. That is 1 by 3 hours. And N, value of N is 2 because his speed is 2 kilometer per hour lesser than his original speed. So N is for lesser. And then the time taken is 40 minutes late. That is 40 minutes more. So T2 is 40 minutes, which shall become 40 by 60. That is 2 by 3 hours. Now let us find out this M, N, T1 and T2, what values do they hold? If the speed of the student is 4 kilometer per hour more than his original speed, so M here stands for more. Please remember that. So the value is 4. Then he reaches his college 20 minutes earlier. So T1 shall be 20. Whereas if his speed is 2 kilometer per hour less, so for less we use N, so the value is 2. And T2 is for late, so 40 minutes late, so T2 value is 40. So just employing these values, substituting them into this formula, we get M into N, that is 4 into 2, into T1 plus T2, that is 20 plus 40, and MT2 minus NT1, that is 4 into 40 and 20 into 2, as is given here. So performing the calculations, 4 into 2 is 8, 20 plus 40 is 60, 4 into 40 is 160, 2 into 20 is 40. So 160 minus 40 is 120. So let this remain as it is, 8 into 60. We have taken this in the numerator. So 60 and 120 gets cut by 2. 2 and 8 get balanced by 4. So his original speed was 4 kilometers per hour. So such kind of questions can be solved using this particular formula. Kindly do not forget. Now look at this question. In how much time will a 200-meter long train traveling at a speed of 72 kilometers per hour cross an electric pole? Now, let us say that this is an electric pole, and if this is to be crossed by a train, let us say if this is a train, then the train will have to cross its complete length. We can say that train has crossed the electric pole completely. The length of or the breadth of this electric pole is taken negligible. It would be in some centimeters, let us say. So as compared to length of the train, the length or diameter of the pole is taken as 0. Now the length of the train here is given to us as 200 meters. This is the distance that it will have to travel because it has to cross itself. Speed is mentioned as 72 kilometer per hour. Time is what we want to find out here. Time we know is distance by speed. Distance is given to us in terms of meters. So kilometer per hour has to be converted in meters per second in case of speed. So the speed given to us here is 72 kilometer per hour. Let's convert it into meters per second by multiplying it with 5 by 18. So that now we get our speed in terms of meters per second. So meter will cancel. Your answer will come in terms of seconds. So this shall be 200 by, well, 18 fours are 72. So 4 into 5 is 20. It should take only 10 seconds for the train to cross itself completely, which means that it will cross the pole in 10 seconds. Now in how much time? So T is what we need to find out here. Will a 200 meters long train, the length of the train is 200 meters, traveling at 54 kilometer per hour, speed is given to us as 54 kilometer per hour, cross a 100 meters long platform. Now the length of the train is 200 meters and the length of the platform is given to you as 100 meters. Now what's happening here? Let us say that this is a platform. Length of this platform is given to us as 100 meters, and as a train is approaching from this side, the length of the train is known to us as 200 meters. And when the train crosses the platform, it has to cross two lengths. First, it will have to cross this length of the platform till here, and then it will have to cross its own length as well. So when do we say a train has crossed the platform? When its last bogie has crossed the platform. So in that case, this train has to cover this 100 meters as well as further 200 meters because it has to cross itself completely. So while finding out time, we know it is distance by speed, and here distance will become the length of the train plus the length of the platform. This shall be divided by the speed of the train into 5 by 18 because we need to convert it into meters per second, because the lengths of the train and platform are given to us in meters. So the time here becomes 200 plus 100, that is in meters, by speed of the train, that is 54 kilometer per hour. So into 5 by 18 to convert it into meters per second. Meters will cancel. Our answer will come in terms of seconds. So 18 into 3 is 54. 200 plus 100 is 300. 5 into 3 is 15. So clearly 20 seconds will be taken by the train to cross the platform completely. Now, in the previous question, the train crossed an electric pole, which was a stationary object of negligible length. The length of the electric pole we had taken as 0. Now, in this case, train is crossing a stationary object of considerable length. And this time, the object that it crosses is a platform which has a length. It could be a tunnel, it could be a bridge, anything which has considerable length which needs to be crossed. So in such a case, the length of the train gets added to the length of the platform. So first case, electric pole, only the length of the train becomes the distance to be crossed. And in second case, that is a case of crossing a platform, the distance becomes length of the train plus the length of the platform. Now what will happen if two trains try to cross each other when they are approaching each other, or let us say when the slower one is being chased by the faster one? Now let's look at this case. If two trains or vehicles A and B, whose lengths are L1 and L2 respectively, and their speeds are x kilometer per hour and y kilometer per hour respectively, and the two trains are traveling towards each other, that is, this is train A and this is train B, they are traveling towards each other. And traveling towards each other means traveling in opposite directions. So both travel in opposite directions. Then relative speed becomes the sum of their speeds. Why so? See, if two objects are traveling towards each other, the time in which they will cross each other will become very less. Why? Because both are crossing each other's lengths. So speed is more because their speeds get added up. And when speed is more, then time taken is less, as speed and time are inversely proportional. Now time taken by the two trains to cross each other shall be L1 plus L2, that is the distance, by x plus y, that is the relative speed. Second case, train B is being chased by train A. Both travel in the same direction. And here, the speed of train A obviously is greater than the speed of train B. Then only train A will be able to cross train B or overtake train B. Now, in such a case, the relative speed will be the difference of the two speeds. Why so? because both the objects are moving in the same direction. So net speed will be the difference of their speeds. So let us say that train B is moving at 80 km per hour and train A is chasing it with 100 km per hour speed. Then the net speed between the two will become 20 km per hour. Because in 1 hour, train A will be able to gain only 20 kilometers of distance over train B. So in such a case, time taken by train A to cross train B or to overtake train B shall be L1 plus L2, that is the distance, the sum of the lengths of the two trains, divided by x minus y, that is the relative speed of the two trains. Let us have a look at a question based on this concept. The lengths of train A and B are 225 meters and 250 meters. So this is L1, this is L2. And their speeds are 54 and 36 km per hour respectively. So this is speed A and this is speed B. If both the trains are traveling in opposite directions, then in how much time will the two trains cross each other? Opposite direction would mean the two trains are approaching each other, which means this is train A and this is train B. So time, as we know, is distance by speed. Employing this formula, we will see time taken is, now the distance is how much? It is the sum of the lengths of the two trains, which are given to us as 225 and 250 meters. So 225 plus 250, this is given to us in meters, divided by the relative speed. Now, 54 and 36, and both are traveling in the opposite direction. So while moving towards each other, A is covering 54 and B is covering 36 kilometers in an hour. So that is their speed. So obviously the speeds will get added up. That would be the net speed. That would be their relative speed. So the relative speed here becomes 54 plus 36. This is in kilometers per hour. So let's multiply this with 5 by 18 to convert this into meters per second. So meters and meters will cancel and our answer will come in terms of seconds. This shall become 225 plus 250, that is 475, divided by 54 plus 36. Now this we know is 90 into 5 by 18. 18 5s are 90. So 5 into 5, we shall take this here as 25. So 25 into 1 is 25. 47 minus 25 is 22. Combined with 5, 225 divided by 25 is 9. As 25 into 9 is 225. So the total time taken here for the two trains to cross each other shall be 19 seconds. Now look at the next question. Lengths of the trains A and B are 225 and 250 meters respectively. So L1, let's say length of train A and length of train B. If their respective speeds are 54 and 36, see the values happen to be the same, but kindly read ahead. Then in how much time will train A cross train B if both are traveling in the same direction? So train A, which is faster as it is traveling at 54 km per hour, is to overtake train B, which is slower and traveling at 36 km per hour. Or we can also say train A is chasing train B. You can say that also. So in that case, this is train A traveling at a faster pace, and this is chasing train B traveling at a slower pace. So time, as we know, is distance by speed. So time taken here shall be the sum of the lengths of the two trains divided by the relative speed. Now what is the relative speed here? It will be the difference between the speeds of the two trains because they're traveling in the same direction. So time here will become 225 plus 250 divided by 54 minus 36, which is in kilometers per hour, into 5 by 18 to make this meters per second, and this is already in meters. So our answer is going to be in seconds. So time becomes 475. Now 54 minus 36 is 18. So this and this 18 will cancel. We'll be left with only 5. So 475 by 5 is what we are left with. So 5 nines are 45, 25 remains. So 5 fives are 25. So 95 seconds or 1 minute. There are 60 seconds in a minute. So 1 minute and 35 seconds. This will be the time taken for train A to overtake or cross train B. Now look at this one. Train A is 250 meters long. So length of train A is given to us here as 250 meters and travels at a speed of 54 km per hour. So speed of train A is given to us as 54 km per hour. If a car, now look at this car, chases this train at a speed of 72 km per hour. Now this is the speed of the car, that is 72 km per hour. Then in how much time will the car cross the train? Now in the previous question, there were two trains, A and B. And train is an object of considerable length, and that is why their respective lengths were also given to us as 225 meters and 250 meters. But in the case of car, please remember the length of a car is considered negligible, that is 0, for the purpose of performing the calculations. So time is distance by speed. So time here is going to be length of the train alone. So length of the train divided by relative speed, which in this case will be the difference between the speeds of the train and the car, because both are traveling in the same direction. The car is chasing the train. So speed of car minus speed of train. So time here will be, length of the train is given to us as 250 here. Speed of the train is 54 and speed of the car is 72. So relative speed becomes 72 minus 54. Now this is in kilometers per hour. Please remember that. Do not forget to multiply it with 5 by 18 and convert it into meters per second, because the distance or the length of the train is given to you in terms of meters. So be very careful when it comes to units. So this shall be equal to 250. 72 minus 54 is again 18. And 18 and 18 will cancel here, the numerator and denominator, and only 5 will be left. So what we get here is 50 seconds. So 50 seconds will be the time taken by the car to overtake or to cross the train. A person walks from A to B and another person walks from B to A. After meeting each other, the two persons complete their remaining journey in 3 1/3 hours and 4 4/5 hours respectively. Now see, what is given here is, there are 2 points. This is point A and this is point B. Now a person, let us say this A, walks from A to B, and a person, let us say this lowercase b, walks from B to A. Let us assume that they meet at this point. After meeting each other, the two persons complete their remaining journey in 3 1/3 hours and 4 4/5 hours respectively. That means the time taken to travel from here to here for A is 3 1/3 hours. The remaining journey, time taken to travel for B from meeting point to A will be 4 4/5 hours. This is the remaining part of the journey for person B, for person coming from B. Now, if the first person walks at a speed of 12 kilometers per hour So speed of A is given to us as 12 kilometers per hour. Then at what speed does the second person walk? So speed of B, or the person who's walking from B to A, we need to find this out. Now to solve such kind of questions, we will use this concept. If two persons A and B travel at x kilometer per hour and y kilometer per hour respectively, and A travels from point P to Q and B travels from point Q to point P, and after meeting each other on the way, A and B reach point Q and P in T1 and T2 hours respectively, then x by y whole square equals T2 by T1. We will make use of this formula. So here let us identify. The speed of the first person is given to us as 12 kilometers per hour. So the value of x here is 12 kilometers per hour. The first person takes 3 by 3 hours to complete the remaining journey after meeting the second person. So T1 shall be 1 by 3 hours, which is 10 by 3 hours, and T2 shall be 4 by 5 hours. That is the time taken by the second person after meeting the first person to complete the remaining journey towards A. So 4 by 5, 4 5s are 20 and 4 is 24, so that is 24 by 5 hours. So let us make use of the formula x by y whole square equals T2 by T1. We need to find out the speed of the second person, that is the person who's traveling from B to A. So making use of the formula, we have, I'll just resolve this here, 144 by y square equals 24 by 5 into 3 by 10 becomes 12, becomes 5. 12 and 144, 144 is a square of 12, so goes by 12. 3 and 12 goes by 4. Y square equals 4 into 25, which is 100. So the value of y here has to be 10 kilometers per hour. That is what we are arriving at as the answer. So many times questions are asked on average speed. Now how do you find that out? If a person travels from A to B at a speed of x kilometer per hour and comes back from B to A at a speed of y kilometer per hour, then his average speed for the entire journey shall be given by the formula 2xy by x plus y kilometer per hour. Now, look at a question here. If a bus travels at 60 kilometer per hour from Delhi to Agra and comes back through the same route at a speed of 40 kilometer per hour, then what will be the average speed of the bus for the entire journey? See, he is talking about average speed, not average. So kindly do not make the mistake of adding up 60 plus 40, taking it as 100 and then dividing it by 2. Like this, 60 plus 40 by 2 is 50. This is average, not average speed. This will be incorrect. So how do we do that? We make use of the formula 2xy by x plus y. So average speed is equal to 2xy by x plus y. This shall become 2 into 60 into 40. Do not calculate this by 60 plus 40 because numerator and denominator will definitely get cancelled. So 2 into 60 into 40 by 100, the zeros cancel. So 2 into 6 is 12, 12 into 4 is 48. So the average speed comes out to be 48 kilometer per hour. Now similarly for this question, if a car travels at 100 kilometer per hour from Bangalore to Mangalore and then comes back through the same route at a speed of 50 kilometer per hour, then what will be the average speed of the car for the entire journey? So average speed, as we know, is 2xy by x plus y. That is 2 into 100 and the other speed is 50 into 50 by 100 plus 50. So this shall be 2 into 100 into 50 by 150. So zeros go, 5 3s are 15. This becomes 200 by 3, that is 3 into 6 is 18, again 3 into 6 is 18, so 2 by 3 kilometer per hour. So 66, 2 by 3 kilometer per hour will be the average speed of the car for the entire journey. Now a biker covers some distance in 10 hours. If he covers half the distance at a speed of 21 km per hour and covers the remaining distance at 24 km per hour, then find out the total distance covered by the biker. Now see, if this is a total distance d, half of the distance shall be d by 2, remaining will also be d by 2. When we talked about average speed in the previous case, we had a vehicle traveling from A to B at speed x km per hour and from B to A at y km per hour. The distance remained the same between the two cities, Delhi and Agra, between the two cities, Bangalore and Mangalore. The distance did not change. So the distance was equal. Now here in this case also, he covers half the distance and the remaining distance. So two halves are always the same. So once again, we can employ the concept of average speed. So average speed, as we know, is 2xy by x plus y. And here the speeds are given to us as 21 and 24. So 2 into x into y by x plus y, which shall become 2 into 21 and 24 as it is, because cancellations will definitely happen. So 21 plus 24 is 45. Now the cancellation happens. So 3 into 7 and 3 into 15 and 3 into 8 and 3 into 5. So we get a 7 into 8, 56 into 2, that is 112 by 5. 112 by 5 is 22.4 km per hour. Now this is the average speed for the entire journey that we have taken. But we need to find out the total distance. So what is distance? Distance is speed into time. So distance is speed into time. So 22.4 km per hour is the speed into 10 hours. That is the time given to us. It shall become 224 kilometers. So these were certain questions and patterns based on which problems are often asked in CSAT and similar kind of examinations. So kindly do revise them and practice as much as possible. We will meet again in the next discussion. Till then, my best wishes. Please take care of yourself and thank you so much.